Alright, factor and remainder theorem, page 357, number 51. The problem says, given one of the zeros of the polynomial function, find the other two zeros. So with given this problem, you have y equals x to the third minus 14x squared plus 47x minus 18. The third degree means that I'm going to be able to represent 3 x-intercepts on this problem. Means this function could touch it 3 times on my x-axis. It gives me that 9 is an x-intercept. So the process at this point is going to be to put 9 in the backwards L and write your numbers down here. And as I do this process, we know in this box I have to end up with a 0. So I drop this 1, multiply, add, multiply, not 92, that's going to be just a 2. And then, oh, I made a mistake here. That's supposed to be 18, not 8. And 9 times 2 is going to be 18 right there. Add those together and I'm going to get 0. So this means a couple of things. One, I already knew that this was going to be 0 because it told me 9 was an x-intercept. Since 9 is an x-intercept, then I know that if I rewrote this in a different way, then the 9 is an x-intercept, therefore x minus 9 would be a factor of that polynomial function. Since I did this process, I can use these numbers to give me another quadratic down here. Once again, remember, if this is a 3 and I just took one number out of it, I'm going to drop this and start with an x squared minus 5x plus 2. So I just rewrote it. I was able to do that with the fact that that was an x-intercept. Now, to find the x-intercepts, there's going to be no surprises with the first one. Since this is equivalent to this, when I set x minus 9 equal to 0 and solve, I of course have to get x equals 9 as one of my x-intercepts because that was what it was in the original problem. Now setting this quadratic equal to 0, I can do one of 3 things. I can factor, quadratic formula, or use square roots. Square roots is not an option, not an easy option here because I have 2 visible x's. So normally right here I would try to factor. And how I would get x squared, I would only have to have an x and an x there. To get a positive 2 and a negative 5, this is going to both have to be negatives, but I have to get a 2 there, so my only options are 2 and 1. There's no way that I can use negative 1 and negative 2 here because that's not going to add to be negative 5. So this is not factorable. What does that mean? I have to use quadratic formula. When something is not factorable, then that means something about the roots, and I'll go over that in just a second. But if it's not factorable, that means something specific about the 2 x-intercepts of this problem. So, as we have memorized, I'm going to do the opposite of b, which b is negative 5, so I'm going to do 5 plus or minus b squared minus 4ac all over 2a. When I reduce that down, I have 25 minus 8, which is 17. And remember, radicals, I'll have to break those down if I can. And I can't break the square root of 17 down because it doesn't have a perfect square in it. So now I know that to make this true, my x values have to be 5 plus the square root of 17 over 2, and then 5 minus the square root of 17 all over 2. If we put those in the calculator and get an approximate answer, do that really quick. This is going to be approximately 4.56. And this would be approximately 4, 3, 8. So these are exact numbers here, except the numbers are irrational numbers because I have a radical in it. When something is not factorable, meaning there's no way that it can be factored, and you use the quadratic formula, that means under this radical you're going to have a number you're going to have an irrational root here. Irrational roots, remember, have the square roots that don't break down all the way to a whole number. So what this says visually is, to begin with, 9 was an x-intercept. One more. There's one of my x-intercepts. Now, here are approximate x-intercepts. Approximately 4.56. So I'm going to go 1, 2, 3, 4, and almost to 5. And then 0.4 is between 0 and 1. So my x-intercepts are there. They're just not whole like my 9. They're not nice, clean, quote-unquote, clean numbers. So to get my sketch there visually, it has to go like this, because the leading coefficient was a 1, which is positive, and my degree was 3, so they go in opposite directions. So the answer to this question specifically is just these two. It's asking for the other 2 zeros. Those are my 2 other x-intercepts.